Hey, Vlad here, devinsid.com, and welcome to the fourth video in the Scala playlist. In the last episode, we talked about scopes and about assignment in the sense of giving names to scopes. And the purpose for that was so that we have a finer control over the flow of our program. So instead of having it run top to bottom, we want to decouple the syntactical structure of our program from the flow of control. Today we're going to continue to explore scopes and learn how to bend the flow of control even further. And by the way, sorry for my voice, I went out last night and the music was so loud so I had to scream. Alright, so I'm in Ubuntu again, and let's open the terminal and put it on the right. And we had a folder under dev called video 3. There we go, video 3. In fact, you know what? Let's rename it. So let's remove. Sorry, not remove. Let's move video 3 to Scala playlist. There we go. All right. So let's go in there and just do subl dot so that Sublime will start. And this is a new instance of Sublime. This is the old one. Let's close it with Ctrl+Shift+W, and we have the new one over here. As we can see, it's exactly the same project. If I open that, there we go. This is where we left off in the previous video. Let's start SBT over here. There we go. Tilde run, compiling, running. It's all good. Okay, so this is where we left off. In the program that we have on the left, we used to print out an empty line in the beginning of the program and also in the end of the program. So our program was actually in between those curly braces. So we were working only in that scope. That's why we have an empty line over here and we have an empty line over here. So firstly, I decided that I think it's better visible if instead of having empty lines, I would just have 50 hyphens. So if I have a hyphen, multiply with 50, it's more visible where our program actually is. So our program is always in between those lines. In fact, let me remove everything from here and just say print line hello world. All right, so now we have 50 hyphens, hello world, 50 hyphens. Okay, so our program is always in between those hyphens, so those lines basically. Okay, so in the last video we talked mostly about vals, defs, lazy vals, and vars. So let's recap. So val is a value, and it is stored in memory. And the important thing about val is that it always executes, right? So as soon as the compiler, or in fact the runtime, I didn't really make a clear distinction the last time. As soon as the I'm just gonna keep saying compiler just to avoid the confusion. So as soon as the compiler reaches this line, it executes it, right? Okay, so so if a scope does not have any keyword, then it executes automatically. If there's a val, it also executes automatically, and the expression inside of that scope, the last expression, is evaluated and it is stored into the val. Now a def is a definition, and which means that only the computation is stored, right? And this also means that it might happen that if we don't reference this def later in the program, that the def will actually never run. Okay, and this is very important for the video today. Actually, lazy val was just a combination between val and def. So the first time it behaves like a def, and the second time, or actually all the other times after that, it behaves like a val. And a var is a variable in terms of execution. So in terms of the flow of control, it behaves exactly like a val, but it can actually be reassigned to a new value later. So it's actually stored in memory like a val, but can be reassigned. All right, so I'm gonna leave these over here for a while, so that you just have a frame of reference. Okay, so the main theme for the video today is to answer the following question: how can we decide if a scope should be assigned to a val, to a def, or to a lazy val, or even maybe to a var? In fact, let's just make it simple. How do we decide if a scope should be assigned to a val or a def programmatically? And programmatically means, how can the program decide if a scope should be a def or a val? So as of right now, what we have done in the previous video, we decided ourselves, right? So in the source code, we went and we said, okay, this scope, right, that thing, let's surround it with a scope. Sorry, we went and we gave it a name, right, some name, and then we decided, okay, this is going to be a val. And the question of this video is, how can the program itself decide that this should be a val, which means how can it decide that it should always run the scope as soon as it encounters it, or the other way around if it's def, right? How can it decide not to run the scope, right? Which means basically making it a def and not referencing it, okay? Now, this might sound very weird and very confusing, but again, even in the first video, I promise you this whole playlist is gonna be like that, because I'm just showing you here. You know, I always said that Scala is my favorite language, not because I think that it's the best one, but because it just fits the way I think. And yeah, in this playlist, we basically explore the way I think, and with the help of Scala, right? Okay. So the answer to that question is actually there is no way to generate code like this, right? Because this is code, right? This is source code. There's no way that we can generate this keyword and insert it into that file. Now, in fact, you know, sidebar, it is actually possible, but it is like way out of the scope of this playlist, right? We're not going to talk about this for the next year or so, right? Okay, I'm exaggerating a bit, but basically, as of right now, I think that this is impossible, right? So this is source code. It gets stored in files. It gets compiled into binary in the end, right? Right, and then and eventually it runs on the processor. Okay, so the code has to be there before the program starts running. Okay, so there's no way to generate a def or a val. Okay, this is not a big deal, however, because there's a much simpler way to handle those things, and today we're going to talk about them. And the solution are so-called if expressions. In some languages they're called if statements. We learned a little bit already in the previous video what the difference between statements and expressions is. So statements, they basically produce a side effect, and expressions, they actually evaluate to something useful, to something that can be stored in a val or in a def. Okay. So before we continue, let me remove that, and instead of hello world, our example is going to be mood. Okay, so we're just gonna print line I'm happy. Okay, and now the goal is to decide should we run the scope or should we not run the scope, and the syntax for that is as follows. So if before that scope, somewhere here, we have an if keyword, and notice that Sublime understands that this is a Scala file, right? So it knows that if is one of the keywords in the language, like an object or like a def or like an if. Okay, and the syntax is that it has to have parentheses like that, right? It's not going to work with curly braces. There are a lot of places. Places in Scala where curly braces can be exchanged with parentheses and the other way around. This is not one of them. So an if expression always has to have those parentheses, right? And inside of them, we're gonna have a scope, right? And the scope has to evaluate to a so-called conditional, right? And there are only two possible values for a conditional. One is called true, the other one is called false. Let's start with true. So if true, print line I'm happy, and if false, just don't run the code. Okay. In fact, let me comment out this part real quick, and before we actually do that, let's do print line true, and the same thing is false. False. Oh, come on, false. There we go. Print line true, print line false, and this is how they look like. Okay. We're probably going to have a separate video at some point dedicated only to conditionals, right? Because it's a whole own story, right? As of right now, all you need to know, there are only two values, right? True and false. Okay. All right. So let's go back to this, this, and that. Okay. So how does this work? Remember that the compiler, when it looks at a program, it doesn't see like we do. So it doesn't have this top-down view on the program. The compiler sees it letter for letter, right? Character for character, like this, like this, like this. So what it's doing is, if it encounters the if keyword, then it looks for an opening parentheses, right? And then it expects the scope to be here, and then it looks for the closing parentheses. So what happens then is that it knows that whatever happens after this, whatever scope is, whatever expression is basically after this closing parentheses, it will only be executed if this scope evaluates to true. Okay, and it doesn't even matter what is in between them, right? I mean, of course it matters, but if we had, like, for example, a bunch of empty lines here, right, and if we let's say move the scope to the right, okay, it wouldn't matter, right? So it's false, so it's not gonna run. It's true, and it is going to run. Okay, so now this is all fine and dandy, but I have never seen any programmer write something horrible like this, right? So usually we have a closing parentheses, and then we have right away this curly brace. So in Sublime, if I just put my cursor over here and I press Control J, which stands for join lines, then it will start removing lines until I stop pressing this combination, right? Like this, and the last time it's gonna do this, okay? And this is what we want. We want one space here. We want a curly brace, and then we take these two lines and we just move them. In Sublime, it was either Control and opening bracket like that, or with a Shift and Tab, right? And you can also move things the other way around with Control and closing rectangular bracket, right? And also just Tab, okay? And most editors do it like that, okay? So we have, if true, just run the scope, okay? Let's do this, and if false, let's do that, okay? And as we already know, if there's only one thing in the scope, then we don't even need the braces, right? Need those curly braces. So we can remove these, right? And we can also remove these, right? This is a common gotcha for Scala beginners because let's say we actually had these, right? We could have print line happy, and we can also say I'm still happy, okay? So if we remove the curly braces, actually let me switch that to false. So false, then none of it is happening, okay? But if we forget the curly braces, right? So if we remove them, all of a sudden this is not one thing. This is one thing. So what's written here is if this expression value is true, and it doesn't, so basically don't run this. But this is not a part of the if expression anymore, so it will run, right? Let's see. So it was false. It was false. So this was not printed out, but this was. So the way the compiler saw this was like this, right? So this is exactly what happened. Okay. Therefore, be very careful with that. And what you can also do is you can have it like that, and this way it's at least it's a little bit more visible, right? That this thing is sort of on the same level, so it always runs. Okay, so let's move it back to true. Right, I'm happy, I'm still happy. False, I'm happy, I'm still happy. So I'm still happy. This is basically just a regular print line. It doesn't have anything to do with this, right? So the compiler does not only see it like that, it also sees it like that, right? So this is its own tiny scope. This is like its own tiny universe. It doesn't care about this, right? Sorry. Save. False. Always this. True. Now this and that. All right. Okay. So let's make it a bit more simpler again. Remove those curly braces. Remove I'm still happy. We have that, and let's remove that as well. Okay, it's because we have a very simple expression. Okay. So let's make this a bit more fun and actually give a better name for true, because right now, why am I happy, right? Okay. Let's say that I'm happy if the day is sunny, right? So let's just have a val over here and say is sunny day, then use sunny day over here, right? So now it reads a little bit better, right? So if it's sunny day, I'm happy, and if it's not a sunny day, then I guess I'm not happy. I don't really know. So if statements or if expressions, in fact in Scala they're expressions, and we're going to get to that point a bit later, they also have an alternative, right? So because conditionals can either be true or false, there should be a way to run an alternative, right? So if we had an alternative like print line I'm sad, right? The way to run it is to have an else here, okay? So because it's not a sunny day, I'm sad, and if it is a sunny day, then I'm happy, right? I guess this is the longest explanation of if expressions that you can find anywhere, okay? And again, the same thing with scopes, right? We can have a scope over here, we have a scope over here, and we could even have a scope over here. But actually, whoops, sorry. What did I just do? Hold up. There we go. There's an error here. Okay, so let's do that. Let's have that scope over here, that over here. All right, so now it makes a little bit more sense. So this val, it relates to this if else. So let's actually move it inside. All right, so let's move it inside over here. Okay, so I'm not saying that this looks more beautiful. In fact, the purpose why I just did that is because I hate curly braces, and this is one of the reasons why I like Scala, because there's almost always a way to structure your code in such a way that your scopes have only one expression, and when they have only one expression, you never need them, right? So if I just press Control Z like a bunch of times, all of these curly braces will go away, and it's just so much easier to read. Again, this is a flexibility that always has a price. Like everything in the world has a price, right? In a sense that I'm not saying that you can buy everything. I'm saying that there's nothing perfect, right? So there's always, this is very flexible, this is very cool, but it also has a price. It can be abused, as you have seen. If you forget curly braces and you have two print lines, and one is always running. Okay, but let me press Control Z a few times, and all of these braces just gonna get removed, and there we go. So this is just much nicer to read because there's less noise. Okay, so I just said that if statements are sometimes called if expressions. So in Scala they're expressions, and it means that we can have a scope around them, right? And like that. I'm not sure what Sublime puts over here, so let's have it over here. So this whole if-else thing, right? It's one scope, right? So it's one expression. So this means that we can assign it to a variable, right? So let's say this is the result, and the result is either this or either that, and over here we can print out the result. Now, before I save, I just want to explain again what it means, that this expression. It means that whenever a compiler is done with it, it produces a result and it puts it over here, right? In Java, for example, this doesn't work. And I believe in JavaScript, for example, it doesn't work. So what they did later is they introduced like a completely different operator. It's called a ternary operator, if you might know it, and it does that. In Scala, you just don't need that. So you might think, who cares if it's an expression or if it's a statement? The thing is that statements basically they encourage vars. And if you've seen my previous video, vars are dangerous, right? So if it was not possible to do this, we would have to have a variable over here somewhere, right, called result, and its value would have to be something uninitialized, right? We haven't even talked about it yet. And then in the if case, we would need to reassign its value to this, and in the else clause, we would need to reassign its value to that. Therefore, it has an immense value that if statements are expressions in Scala. Okay. Anyway, let's print it out. Let's print it out and see what's going to happen. So we have the I'm happy over here, right? And because it's true. But what got stored into this is the result of the scope, and the result of the scope is not this, right? It's this. And if you've seen my previous video, the result of this is nothing useful, right? Because this is a statement. So we're coming back to statements. So in fact, a better version of this would be to actually produce a value instead of having a statement over here. So let's just remove those print lines, right? And all of a sudden we have the string, right? It's either I'm happy or I'm sad, and then this guy is just going to print the result. So in fact, the behavior is exactly what as we had it before. Right, but now we actually see that if it can be used as an expression. So if it's true, then I'm happy is assigned to result, and then it's printed over here. And if it's false, then I'm sad is assigned to result, and the result is printed out over here. And again, just to recap a little bit, right? So if we did not have that print line, right, then let me change this to true real quick. Then I'm happy is still assigned to result, right, because it's a val. But we're not using it, so it's kind of useless, right? So let's do that. So now we don't see anything, right? But if it's a def, then this whole thing is not running, right? This whole thing is not running, and it means that even this is not evaluated, right? So this is a val. So basically, if this is a def, then we could also save some performance. We can improve performance with having a def over here, right? Let's actually make this a little bit more visible. Let's introduce a scope around this, okay? And say over here, So before we return true, say print line in is sunny day. Okay. Where is it? Where is in sunny day? It's not there, right? As soon as we turn it to a val, all of a sudden we will see is sunny day, right? In is sunny day. So it ran over here. We don't see this, right? Because we're never printing out this result, right? But now it just ran for basically no reason. At least now there was a reason. Now, why did I start talking about this? I started talking about this because this whole control of the flow, right? This control of flow of control that we have as programmers actually has a crazy cost, right? So as a programmer, you have to look at this code, and it's a tiny piece of code, right? And you need to understand exactly which part of it is running and which part of it is not running, because well, there are many reasons, but one of the reasons is that these codes might have contained statements, and it's really hard to reason about them, right? So it's you have to, when you look at this code, you have to be sure, is this thing going to run or not? This is why I'm spending more than one video on explaining scopes, on explaining the flow of control, and this is why I'm doing it in this like super weird way, because I believe that this is the very fundamental knowledge for every programmer to have, and this applies to most languages. It's just that in Scala it's very, very evident. Okay, let's go back a teeny tiny bit and finish talking about the if expressions real quick. Okay, so let's just say that this is a true and this is a val, and yeah, we're just gonna print out the result. So what I wanted to show you is that it is also possible to keep branching out this thing. Okay, so we don't only have if and else, we also can combine if and else, and for that we will need to introduce a second variable just to show this. We're gonna call it is rainy day, right? As of right now, we're just gonna set it to true. Okay, so what we're gonna have here is I'm happy because it's sunny, right? Otherwise. And it's the same structure, right? Else if, and now we're gonna say if it's a rainy day, right? I'm gonna be sad because it's raining, right? Otherwise, not sure how I feel about today. Okay, right. Again, this is a very simple code, but you should really see how important it is to know which code is actually running and which is not. So for example, if a sunny day is true, right, then this whole thing is not running. Is rainy day is also not evaluated, right? So it doesn't matter if it's a val or if it's a def over here, right? Let's actually have a tiny scope over here and say print line in that thing, in is rainy day. Okay, so now it's always running, right? And now it's not running, okay, because this is true, right? So it doesn't even evaluate that. And I'm going to show you why this is important. So if it was a val, right, you would say, you know, it's always running, right? If it's val, it's always running. We're going to simulate that this value is coming from far away, right? So assume that we're fetching it from a database, or we're fetching it from the network, from some remote server, or maybe it takes just forever to calculate this true, right? Okay, and the way we simulate this is like that. We'll say thread sleep, and we just give it seconds. Let's give it 5 seconds, and the value we give it is in milliseconds, which is why I have to multiply with 1,000. So let's see. So now we're waiting for 5 seconds. 1, 2, 3, 4, 5, and only now it's actually saying I'm happy because it's sunny, right? But it was here, right? There was no need to wait for that. So if you're careless about vals and defs, you're gonna waste time. Okay, so if you're gonna have a def, it's still gonna say I'm happy because it's sunny, right? But it's just not gonna run this code, so it's not gonna wait. It's like this, boom. Again, this is exactly why I'm spending more than one video on this. This is super important. Real quick, just to explain this thing a bit more, let's actually have another print line over here and say after is rainy day. So technically this is not true because we're still inside of rainy day. I just want to say let's say this after this thing. Okay, yeah. So and let's have here over here we're just gonna say before, right? We're gonna say before. Now because it's a def, it's not running, right? So maybe let's just turn to a val, okay, so that you see. Okay, so before is executed right away, and only after 5 seconds we're gonna see this, and then the rest of the program. But the rest of the program happens so fast that you don't even notice it. Okay. All right. So let's revert all of that. So this whole scope evaluates to true. So let's just say true. Right. Same thing. Okay. And let's also have a def over here. Okay. So the first one, the sunny day, it is always evaluated, right? So we can safely leave it as a val. However, as soon as we turn this thing into a def, not the same, right? So now, imagine the thread.sleep thing was over here. So now we have to be more careful and optimize a little bit, right? So for the rest of this example, it's not going to matter if it's a val or if it's a def. In fact, we're almost at the end of this video. It's a short one, finally, right? I'm just going to leave them as a def, right? So let's trace it actually. Okay, so if sunny day is true, then this is the case that we just talked about for so long anyway. Then all of this is not going to matter, right? It's just going to run this. However, as soon as it's false, right? Then we're going to look at this, right? So we're looking at this. So is it a rainy day? Well, it's true. So we're going to run that. So only if both of them are false, right? So if that's not true and that's not true, otherwise do this, right? Only then we're going to see this, right? So now we're seeing this. And in fact, I didn't let the previous one run. So false, true, false, nope, true, yep, right. By the way, real quick sidebar: if you actually started playing around with Scala, so if you're actually doing this and not just watching it, which you should, if you don't like false and true, you can do a teeny tiny trick because you already know defs and vals and whatnot. Just have somewhere, I don't know, somewhere over here, just have def yes equals true, def nope equals false, right? And now you can say is sunny day? Yes. Is rainy day? Let's say yes. Actually, it doesn't really matter, right? Because if sunny day, if it is a sunny day, then we're here, right? Let's put it to no, and have it over here, said, right? And if they're both no, then have it over here. Not sure how I feel about today. Yeah, but just please don't do this in production. So once you're an actual developer, we hate this. So just do it when you're playing around, okay? Just for fun. All right, let me revert that. Let's have a true here. Let's have a true here, and remove these. All right. All right, so we're actually in the end of this video. What I'm gonna do now is I'm just gonna give you a sneak peek of the next probably 2 videos. The first one is going to be about types. We haven't talked about types. Types are things like these over here. This is a type. So this is args, and some variable and some scope. I haven't explained that whole thing yet. And this is a type. Okay, true has a type, right? False has a type. This is of a type string. This is of a type integer, right? So we haven't talked about it yet. I want to show you why types are important a little bit, and we're going to talk about it in the next video. So this is just a sneak peek, right? So because we are printing out the result over here, it doesn't really matter what type the result has, right? Because print line can print out anything, right? So let me remove the whole thing. Let me print out. So it doesn't matter if you print out a 10, if you print out a true, or if you print out a true as a string, right? So print line doesn't really care. Therefore, if we go back to our code from before, okay, and if one of those branches all of a sudden is not a string, right? Let's say 10 over here, right? And it doesn't matter. It doesn't matter if it's true or false, right? Because I'm gonna explain this whole thing much better in the next video, right? But basically, just listen. It doesn't matter if these guys are true or false. It doesn't really matter because we're talking about compilation actually. You know what we should do? Let's do this. So Scala is statically typed language, which means that it compares types during compilation time. So now we're not gonna run anything. We're just gonna compile. Right, we're just going to compile. So does the program compile or not? That's all we care about. Success. Okay. As soon as we have a 10 here, right, it's still going to compile. But if we actually start running it, we're going to see 10, right? And if this is false, I forgot to tell it. If this is false, then we see this guy. So it looks like Scala doesn't care. right? But in fact it does. And you just don't see it because, again, println doesn't care, right? So Scala cares, println doesn't. The compiler cares, println doesn't. Okay, and again, we're gonna talk about it in the next video probably. The way you actually see this is by using the result in some other way. For example, there's a way to reverse strings, right? So if these are strings, you can just say reverse over here, dot reverse, and then the string is reversed, right? So I'm sad because it's raining. Jesus Christ, it's so hard to read it from right to left. As soon as it's a 10, right? And I'm not even gonna try to run it. You know, let's compile it. Right? As soon as we have a 10 here, all of a sudden it's gonna say reverse is not a member of any, and any is a type. It's a thing that I'm gonna explain in the next video. Okay, so basically right now it doesn't know is the type of result, is it an integer or is it a string, right? Therefore it says, okay, this is just some type, right? It's called any in Scala. So this is just a type called any, and therefore there's no way to reverse an any. So if in every case a number is coming back, right, it's still not going to work, but the error is going to be different, right? Because now it's gonna understand, okay, so now a number is coming back, right? An integer is coming back, but it's still going to say the same thing. It's going to say value reverse is not a member of, in this case, int, right? So let's compile it, int, right? But because it's an int, we can do other things, right? So we can, for example, say result plus 100, right? So now we actually see, okay, now it's just compiling, but if we run it, it's 111, right? So we were here, 100 plus 11 is 111, and let's just to demonstrate that it works. So now we're here, so it's going to be 110. Okay. Tricky thing, there is a way to there's a way to plus, you know, to add strings together as well. So if I just remove all of these numbers, right? So if I'm just going to remove this, then all of a sudden it's going to be a string, right? And the 100 is just going to be here, right? One of those funny things. Okay. Again, we're going to talk about everything like this in detail, and if you want to avoid that, and there's a way to specify the type. So if you just have a colon here and say, okay, I'm expecting a string over here, right, then it's going to be fine. If you don't say that you're expecting a string here, like that, right, then these both of these things will work with numbers, right? 10, 11, and 12, right? But if you actually say, okay, hold on, I'm just expecting a string, and if something else is coming back, then it just means that I made a mistake, right? So it's just going to say type mismatch, right? So it found an integer, but it required a string because we said that we require a string. But if we don't help the compiler out, right, it's just going to work, and we're never going to know. Okay. So this was a sneak peek for the next video, and there's going to be now I'm going to do the sneak peek for the next video. Okay, so now we don't care about the types anymore, so let's revert this, revert that, and revert that, right? So now we have our, I'm happy because it's sunny, right, because both of them are true. So this second video is going to be about functions, which is a misnomer, by the way, in programming. And basically, it's those scopes that can have an arrow that goes inside of them. Okay, and so if you look at this, if you look at the result over here, it looks like an algorithm, right? There's some logic over here. There's some decision making over here, right? And it looks like there's an input to that algorithm, and the input is over here. And the next video is going to be about how do we separate these, right? Because as of right now, the algorithms and the input, they are in the same scope, right? But how do we have it in such a way that they're in different scopes, right? And they can talk to each other. Let me demonstrate that real quick. So if we try to separate them right now, right? So let's have a scope over here. So they're sort of in one scope, right? And this thing is another scope, right? So you might not see it, but as of right now, they are separated, right? So it's going to say not found value is sunny day, right? Because is sunny day is all of a sudden in a different scope. So the reason for that is that we want to have this algorithm like in one file, for example, right? And the input would be in a different file. So notice, for example, how this scope, right, not the one that I commented out, but like this one, right, it's fine and dandy, right? So it has everything that it needs. You know, there's some warning, but as of right now, I don't care. It has everything that it needs, okay? But this one doesn't, right? This one says, hey, I don't know those things anymore. So we're going to talk about it in depth in the second video. But as of right now, we're just going to revert this, and the sneak peek is going to be the fact that things can be referenced by their fully qualified name, so to say. Okay, so as you can see, for example, over here in main, we have a def main, right? And we haven't talked about it much, but we can also have another def here, right? We could say def high equals high. Okay, now let's just call it hello, just so that you see the difference. And let's comment out all of this, right? And just over here, we're gonna say print line high, right? So it has access to that thing, right? And what we could also do is we could say main.high, right? So you can look at this as if this was just a bucket with code or something like that, right? So this is just a scope that you know that has a name, and then everything that is inside of it you can reference like this, right? So main.high. And the thing is that if we had another object, right? Another object, let's call it far away, right? And we would just put high in there, right? Goes down over here, right? Then now all of a sudden we could say over here, actually let me remove that. Let me remove that so that we can see everything. Let me also remove that. All right, so now you can see everything. Okay, so we have main.high, now we have faraway.high. Okay, so now this object is sort of far away and this code still works. One of the things that SBT is doing for us is that it doesn't care in which files these objects are. By the way, you know how the compiler doesn't like it if you have, I don't know, two defs with the same name, f equals 10, a, why did I say f? It's an a. What the hell? Okay, it doesn't matter what the value is actually, right? So it can be the same value or it can be a different value. It's just always going to say the conflicted method A was defined at line 7, okay, and column 11, right? So this is line and this is like a column 11, right? So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So this is the 11th one, right? So this is why it says 7, 11, all right? So the value doesn't really matter. So the same thing happens for objects, right? So if I were to call this guy main, it's gonna give me like a similar thing, right? It's gonna say main is already defined in object main. Okay, let's call it far away then. Okay, and let's create let's actually press Control KB and create another file over here. Let's call it far away.scala, and let's just cut this guy out, save the file, put in here, and SBT just magically links those files together. So in a sense, println is an algorithm, right? And somehow that high thing is somewhere else, right? It's far away. So we injected it somehow into the println algorithm. And this is going to be the topic of this second video. So the next video is going to be about types, probably, and the video after that is going to be about functions, which I believe should not be called like that. All right, that's it for this video. Please let me know in the comments if you like this style of videos, because this playlist is super important to me. I always wanted to make it like this. I wanted to explain Scala in a way that I actually see it, and I really need to know if you guys understand this, or if it's just too crazy, or if it's too slow, or on the other the other way around. Is it too fast, or maybe you think that you know, this way of looking at Scala is kind of silly. Let me know. I'm really curious. I really want to make this series better. There's still time for you to improve it, because I'm recording my videos a little bit in advance. So you know, if you're gonna give me feedback, a few videos are still gonna be like in the old style, right? But I really want to improve them, right? So let me know what I can do better the next time, and yeah, see ya. Cheers.